let's draw some very simple graphs like this. This is really easiest to understand in terms of examples. Here is the first example. It's full binary shift. So we divide our world in two regions, left and right. We've done this often with unimodal maps before. And we label one of the nodes 0 or 1. Let's get 1. And the other node we label 0. If you look at what we did with unimodal maps, that's how it worked. And then we allow a transition from 1. So this matrix, values of this matrix are the values you associate with the links. So we allowed that one. And we allowed to go from 1 back to 1. Or we go from 0 back to 0. Or we go from 0 to 1. Now what does this mean as a matrix equation? Well, it says it's a matrix that acts on two indices. So if there's a vector here which had value 1 or 0 or 0, 1, that means I start in node 1 or I start in, and that this tells me what can happen next. And it's very permissive. It says from each node I can go to every place. So it's a full matrix. And that's a transition matrix for the two-node system. So that's terribly simple. Now here is an example which is slightly more complicated, but you have done it a long time ago when you look at the three-disk system. And this pinball game is really, really a boon. It's so intuitive and easy to play. In that case, we had 3 disks. I'll draw them as 3 nodes and give them some names. So here is disk 1. I'll make them very small, so you can think of either as a disk or as the nodes, but now they mean the nodes of a graph. Possible places where you can land in a system: 2 and 3. And now what's the allowed dynamics? I can go from 1 to 2, or I can go from 1 to 3. So as I'm bouncing, there's a bit straight line, but straight lines are inconvenient for this drawing. Or from 2, I can go back to 1, I can go to 3, and from 3, I can go to 2, or I can go to 1. And that's it. Everything is permitted. So now we have a matrix. Now, remember, if I start from a disk on a straight line, I can't intersect it ever again unless I hit another disk before. So here we were able to be in partition and stay in it. For the 3-disk system, we must move on. So something like that is totally forbidden. You're not allowed to go back. So what's a transition matrix for this case? It's 3 by 3 matrix. There are 3 nodes. And I'm not allowed to stay on a node, so diagonal is 0. But I'm allowed to go from each one of them to 2 other places. So I'm allowed to do that. And this is the same information as drawing the graph. So on the level of what we have done so far doesn't seem to be a big deal. Of course, I can either draw a matrix or draw a graph, but later on I'll find graphs more intuitive. But at the moment, it's just a matter of taste. Once you start computing determinants of graphs, it won't be a matter of taste. It'll be very helpful to think this way. So that was a 3-disk billiard pinball game. And the last example it has a funny name, but you'll understand in a few lectures why. Golden mean pruning. And here's the simplest rule of what can happen to dynamics of this type. Suppose that dynamics is set up in such a way that if I'm region 1, I'm forced to leave it. So sequence of 2 consecutive ones, and these lines mean anything else, is pruned. That means in my symbolic dynamics I'll have only walks in which no 2 consecutives 1 happen. How do you do this in terms of the diagram here? Well, if you're at 0, there is no rule, so you can do anything you want. You can go this way. And you can also go to 1 as your next visit in your partition sequence. But from 1 you can only come back. So this thing of hanging around 1 is excluded by the pruning of these sequences. So this is a simple grammar. So alphabet is 2 symbols. These are not really numbers, it's just convenient for us to call them numbers, 0 and 1. And now the transition matrix says that if I start at 0, I can go either way, end up in 0, 1. But if I start at 1 and I multiply it, I'm not allowed to go further. So the matrix is pruned, which means some of the links which are the entries of transition matrix are set equal to 0. These things are not allowed. Now you can play quite complicated games with this, but I'll leave it at that and maybe give you some exercises to work it out further.